So today for 8.4 notes, this is day 2 on ellipses, we're going to convert equations that are not in standard form into standard form. So it's kind of like what we did with the circles. This first equation that we've been given, this is an ellipse, but it is not in this form or this form, the one that we worked with yesterday. When it's in standard form, like these, we can graph very easily. We know where the center is, we know if it's horizontal or vertical, we know a lot of information. Here, though, we don't know anything. So here's what we're going to do. We're going to do exactly what we did with the circles. We are going to complete the square. It's the exact same thing. We're just going to find that there's a little difference, okay? So let's go ahead and look at this first equation. Right now, again, just like how it was, we have the x's and we've got the y's. Okay, so here's what we're going to do. We're going to complete the square. Now, before we would complete the square, okay, so if I write this out, if I start writing this out as 3x squared plus 12x, I cannot start adding some number, okay? I do not add 36 here, okay? This doesn't work. Okay, what we have to do is we have to make sure that there is nothing in front of the x squared. So just like what we did before in completing the square, when there's a term in front of the x squared, we have to factor it out. So what we're going to go ahead and do then, we are going to go ahead and factor this. So let's go ahead and factor out the 3. Okay, so if I factor out the 3, oops, wrong color here. If I factor out the 3, and we're going to have our leftovers, okay, so what's going to be left over of those x's? Well, if I divide a 3 out, I'm left with x squared plus 4x. Now I can go ahead and add the number, okay? So here is your b divided by 2 squared, that would give you 4, okay? All right, so we went ahead and took care of the x's. Let's do the exact same thing for the y's. Let's make sure we got enough space here. So for the y's, I have to factor out the 9. So if I factor out the 9, what's left over? Y squared plus 2y plus, now I can add the number, okay? You can only do that when it is y squared, okay? Can't do it when there's a number in front. So we had to factor out the 9. We're left with y squared plus 2y. Now this is my b, divided by 2 and square it. And we are left with a 1. Okay? And that equals, that is going to equal, which we'll have to zoom out a little bit. That is going to equal 15. Okay? All right. Remember though, if we add some number, if we just added these two numbers, okay, this 1 and this 4, we're going to have to add them to the other side. But remember, this time, we do not add 4 and 1. Remember where these numbers are. They are on the inside, so that means I have to distribute this 3. Distribute the 3 across. So really, we are adding 12 to this side, okay, because we have to actually distribute. And we have to do the exact same thing with the 9. I have to distribute that 9. So that's 9 times 1, so therefore we add 9 to this side. So this is just like completing the square before. This is not anything new. Okay, we've done this. So let's go ahead and factor now, because what we have just done is we have created our PSTs. So those are our PSTs. Now, I'm going to go ahead and keep the 3 out in front. So the 3's out in front. What does this factor to? Okay. What does x squared plus 4x plus 4 factor to? That would be x plus 2 squared. Okay. Then plus, I'm going to keep the 9 in front. And then this perfect square trinomial, y squared plus 2y plus 1, that gives us y plus 1 squared. And that is going to equal, well, what is 15 plus 12 plus 9? So that would give us 20, let's see, that's 21 plus 15, that would be 31, 36. So that would be 36. Okay, Well, here's the thing. We're not fully done yet. This is not a circle, okay? So I'm not just done here. This isn't my radius, okay? Remember, we are using these two equations. And what do you notice about these two equations? They are both set equal to 1, okay? So I can't have this as my final equation because it's not set equal to 1. So I need to do something. How do I make this 36 into a 1? I could divide by 36. If I go ahead and divide this by 36, anything divided by itself is just 1. So that means this is going to work out. But I'm going to have to do that to everything else. I'm going to have to divide every other term also by 36. So what does our final equation get to? Okay, so below here. So first, I have 3 over 36. Well, what would that reduce to? Okay, so 3 over 36 3 over 36 reduces to 1/12, okay? So that means this, I can rewrite this then as 3 over 36 as 1 over 12. So this is going to give us then, okay? This is going to give us 1 times x plus 2 squared over 12, okay? And then what would 9 over 36 reduce to? Well, this would reduce to 1/4. Okay, so this would reduce to 1 over 4. So this would give us 1 over 4. So 1 times y plus 1 squared all over 4 equal to 1. And this is technically my final answer. I don't need to put the 1s in front, so these are not incredibly necessary. So it's really just x plus 2 squared over 12 plus y plus 1 squared over 4 equals 1. Now, if you don't feel 100% on that, let's just try one more example to see if just doing another practice will help out. Okay, so let's try number 2. Let's now try number 2. Okay, so with number 2, let's do the exact same thing we did. So what we're going to have to do is turn this equation that is not in standard form into standard form. So just like we did before, let's go ahead and complete the square twice, once for the x's, once for the y's. But again, this time, we're going to have to factor out the number in front. So for the x's, we're going to have to factor out a 4. For the y's, we're going to have to factor out a 3. So let's go ahead and get that started. So with the x's, I'm going to factor out a 4. I'm going to go ahead and factor out the 4. And we're going to be left with x squared plus 10x. And now I can go ahead and complete the square, so plus some number. Then I'm going to go ahead and do the exact same thing with the y's. I'm going to factor out the 3, and what's left over? It's going to be y squared minus 12y plus some number. And that is going to equal negative 136. All right, so what are these numbers we're going to add? Well, here's my new b, so divide that by 2 and square it, and we get 25. And then for the blue here, for the y's, here's my b divided by 2 and square it. We are left with 36. Okay, but remember, we are going to have to distribute this 4 across. So 4 times 25, that gives you 100. So that's what we're going to have to add to the other side. We're going to have to add 100 to this side. And then I'm going to have to distribute the 3 times the 36. So 3 times 36, that's going to give us 108. So I have to add negative 136 plus 100 plus 108. And let's see what we get here. So we get negative 136 plus 100 plus 108, and we end up with 72 on that side. So we have, it's going to be equal to 72. Okay? All right. So now, there are perfect square trinomials. So if we factored those, again, the 4 is going to be out in the front, so that's going to be 4 parentheses squared. So this is going to be x plus 5 squared plus 3 parentheses squared, so this is going to be y minus 6 squared. And then it's going to be set equal to 72. So we're just about finished, okay? But the only thing is, it has to be set equal to 1 in order to be a perfect ellipse in standard form. So what we're going to have to do is divide everything by 72. Divide everything by 72. So we're going to have to reduce 4 over 72 first. So what does 4 over 72 reduce to? That would give us 1 over 18. Okay, so I'm going to rewrite this then as, I'm not going to put the 1 in front this time. This is just going to simply be x plus 5 squared over 18 plus, okay, what does 3 over 72 reduce to? So 3 over 72 is 1/24. So that is going to give us y minus 6 squared over 24. And that is going to equal 1. So this is our final answer. The only thing we had to do extra this time with ellipses is we had to just divide in order to get 1. 72 divided by 72 equals 1. That's the only thing extra we have to do. And notice now we have the equation. This looks exactly how it does before, where we have our a squared, okay, is the 24. The b squared is the 18. So that tells us, since the bigger number is with the y, this would be a vertical ellipse. So our ellipse would look something like a vertical ellipse, which we can go ahead and answer the questions here. The question that it asked was the direction and the center. We can answer that just by looking at here. We just answered it. Okay, this is going to be vertical. So we will go ahead and put that down as vertical. And the center, well, here's your h, there's your k. So it'd be -5, +6. And we are finished.